All right, so we just got done learning about a conditional distribution and how we use it to compare the relationship between two categorical variables. In this lesson, we're going to continue with that and learn a new type of graph that you can use to look at conditional distributions. It's a very useful graph that was actually one of the topics added to the AP curriculum recently. So it's not in our textbooks here. So this is kind of a standalone little deal, just a quick lesson on something called a mosaic plots. All right, and for this lesson here, looking at a mosaic plot, we are going to look at a set of categorical data like we could have looked at in our last lesson. We're asking teachers and students at a high school, and we're asking them how much homework is optimal for a typical class in a night. Okay, so how much homework should students have in a class per night? And it's broken down for the choices. We got students and teachers right here for the groups. And for the choices, we did 30 or less, 30 to 60 minutes, 60 to 90 minutes here. So looking at our data set, remember when you want to analyze the relationship between those two variables, the first thing you do is decide your likely explanatory or X variable. It makes more sense that your group, student or teachers, would have an influence on your homework status, homework thoughts, rather than homework thoughts having an influence on group. So since group is my X variable in this problem, or my likely explanatory, I would want to break them up this way into percentages, which has already been done for us here. So we have 200 students, we have 25 teachers, and the percent of people who think each thing is written down right there. So what we would do at this point is we would turn to one of our graphs that we've learned about. We did the side-by-side bar graph, and we did the segmented bar graph, and those were both great. I think I ended up going with a segmented bar graph here. Yeah, so if you look at this graph, you can tell pretty clearly. I'm not going to make us write out this bottom part right here to describe the association, but you can see very clearly how much more popular 30 minutes or less was with the students right here. That's the vast majority of students who chose it. Whereas for teachers, that was a lot less popular. Little under 20% said that. Most teachers felt that it should be in the 30 to 60 range. So you can look and contrast the differences between the groups. Clearly, there's an association. Teachers are more likely to think 30 to 60 or 60 to 90 is appropriate, where students overwhelmingly believe 30 minutes or less is the most appropriate. This is fake data, by the way. I just threw this together. So if you're insulted by it or I misstated what you think or something like that, it's just a quick example right here. But yeah, looking at this picture, you can see that there's a definite association between the two variables. So this graph is fine and good right here. But the one thing that this graph doesn't represent is the weight of the two groups. So if you look at this graph right here, it kind of sets students and teachers on like an equal playing field where they're both like, you'd be caring about each of them equally here. And in real life, it probably does make sense, even though teachers are outnumbered, from my opinion as a teacher, like our opinion should matter as much as students do. So you should consider both groups equally. But in some contexts, maybe even this one you guys would argue, it makes more sense to look at the raw number of people. So if you look really quickly, again, I want to remind you guys, there were 200 students in this survey and only 25 teachers. When you look at the graph like this, it makes them look like you lose that information and it looks like both groups were similar in size. So that's where our new graph called a mosaic plot comes into play. The mosaic plot is going to take this information you guys see right here, but it's going to display it in a sort of two-dimensional way instead of just equal sized bars. So everything going on with the y-axis right here, our percentages, is exactly the same. This bar reaches just as high as it did on the last slide. The teacher's bar reaches just as high. The breakdown in that sense vertically is the same. What changes in a mosaic plot is the width of the bars. Now, in an earlier lesson, we talked about misleading graphs and how you don't want your bars to be different sizes because it can be misleading and make you think wrong things. But what you do in a mosaic plot is you make sure that the width of the bars is proportional to how much of the total group that actually was. For the students right here, there were 200 students out of 225 because you add on the 25 teachers. If you divide that, I believe that's like 88 or 89%. So what happens is that this bar is 89% of the total width right here. And then that last 11% or whatever it is the length of this bar right here. So when you do a mosaic plot, the other axis, they're not just equally sized bars. The other axis represents how much bigger one group is than the other. So a wide group means that that group was more of the population, more of the sample who was actually surveyed in the problem. So why would this be helpful here? This is useful if you want to know just total people, most popular opinion overall. Because before, when you looked at it, you could be like, well, the teachers think this or the students think this, and those are probably about equally popular. Like maybe dark blue is a little more popular than light blue, but they're probably pretty close. But if you look at the mosaic plot, though, it becomes very obvious that dark blue was the biggest, most popular answer in all. So a mosaic plot brings in that extra dimension and lets you see the sample size by kind of creating the right width to go with it. So this is a nice graph that has its uses as well, and it's especially useful when you have groups of different sizes. So what information is more apparent in the mosaic plot? The size of each group becomes relevant here. It becomes more visible. So sometimes that can also be a useful thing to look at when you analyze conditional distributions.